Moving on here, our next speaker is Dr. Ryan Ziegler, who will be talking about requesting NASA's Astromaterials samples, a how-to guide. Dr. Ziegler has been the Lunar Sample Curator in the Astromaterials Acquisition and Curation Office at NASA JSC since 2012. As the lunar sample curator, he has been responsible for the safety and well-being of the Apollo and Luna samples in NASA's collections, and responsible for providing those samples to approved PIs for a wide variety of studies. Ryan got his bachelor's in geology from the State University of New York in Potsdam in 1998, and his master's and PhD in Earth and Planetary Sciences from Washington University in St. Louis in 2004. Most of his recent research is focused on the use of XCT, X-ray computed tomography scanning, to characterize astromaterials, both from the point of view of curation and for his own scientific research. Take it away, Ryan.
All right. Well, how's everybody doing today? First off, I'd like to thank the LPI for organizing this and inviting me here to talk. Excited to get a chance to share all this with you. You're probably sitting there wondering, well, why should I listen to, this demented-looking Santa Claus here about lunar sample curation or sample requests in general? And over the last 12 years, almost 13 years, actually, I've had the privilege to read about 700 different Apollo sample requests, and then participated in a couple dozen other sample requests as either a PI, a co-I, or a collaborator across the different collections. So I've seen a lot. So I've seen the good, I've seen the bad, and I've seen the ugly. And I thought what we could do today is go over some of the stuff that Jem has already talked about in a little more detail, and then I'll give you some anecdotes that I think will help you as you try to plan your next sample request. So, all right. So there's going to be a certain amount of overlap between what Gemma already told you and what I told you. I'm not flexible enough in my presentation giving skills to just skip it. So I'm gonna reiterate. As Gemma said, sometimes reiteration is the key. And so, the Astromaterials Acquisition and Curation Office here at JSC is the past, present, and future home for NASA's Astromaterials sample collections. We've been doing this for over 55 years now, and continuing to look forward into the future. And so, we have a couple different competing goals. We want to provide the samples to the worldwide community in a transparent and unbiased way. We'd really like to maximize the scientific return from each collection, while at the same time, we want to preserve a significant portion of each collection for future generations of scientists. That's why after 55 years, we still have enough of the Apollo samples and a wide variety of Apollo samples that people can still request, and we can fill most of the different requests we get. And so I'm going to spend the rest of my talk, explaining the sample request process, and we'll give you some specific examples of do's and don'ts that should make this process easier to you. What I'm not going to do, however, is break this down by collection. And first, we're going to talk about how to write a lunar collection, a lunar sample request. Then we're going to talk about how to write a meteorite sample request. This surprised me when I had planned to do this talk, say yesterday, and I started to make it. I realized that wasn't really the right way to do it. In my preparations for this, I talked to all the other, or almost all the other sample curators. I tried to avoid that, but I took one for the team, for you guys, and sat down with the different curators and some of the lead processors and asked them, what are the things you've seen over the years, decades, depends how long they've been doing it, that, keep popping up and that, really help people out when they write this. And as I made the list across the different collections, I realized, wow, they're awfully similar. And so while there are some very specific examples that we'll sprinkle in, and I'll probably talk about Apollo more in the other collections because it's better, because I'm more familiar with it. By and large, what I'm going to say about how to write a better sample request is applicable across all the different collections. All right, so here's sort of the one slide summary of how this works. And so, Gemma just talked about this. So requests can be submitted at any time, via email to the relevant curation curators. Apollo, Antarctic Meteor, and OREX, we do this biannually, and we have deadlines, and they're set about 6 months apart. We just missed the deadline 2 days ago for lunar and a couple weeks ago for meteorite. But they're roughly in May and November, although the exact dates, shift. Those deadlines are announced in the Astromaterials newsletter and on our website, and the links here will be useful to you, I think. All of our other collections are on a rolling basis, and then each request is reviewed by a peer-reviewed panel, the Astromaterials Allocation Review Board. For those of you who've been doing this for a little while, you might know this as CAPTEM, but now it's AARB. Eventually, after AARB has reviewed the proposal, they'll make a recommendation to the individual collection curator, who will make whether they think it's an appropriate use of the samples, and then the collection curator will make a final recommendation on the allocation of samples, which is then goes to Gemma for approval, and then on to Kathleen at headquarters for concurrence and final approval. And so once the decision process has been made, then the collection curator will reach out to you and communicate that decision to you, whether it's good news or bad news or somewhere in between. And then after that, there's loan agreements and security that has to be in place before we get the samples to you. If it sounds like I'm going kind of fast through this, it's because we're going to talk about a lot of this in more detail individually. So, all right, so that's sort of the broad picture of how to do it. But how do you know what to include in your request? And Gemma really went through this a lot already, but the key is on our website. If you go to the website across each of the 9 different collections, you'll see that every collection has a template that you can follow that tells you exactly what we would like to see in a sample request. And it varies a little bit from collection to collection. I've got a screenshot from the Apollo page here, and you can see that it's not really a form you fill out. It's more of a rubric or an outline of things that you should tell us. And if you don't, it's going to negatively impact your ability to get samples. And other collections have actual forms. And so here you can see the form from the Antarctic Meteorite collection. And this is actually directly from the Word document that you can download. And this is the sample of how to fill it out. One of the most important things you can do is not try to fill out the sample page, because if you do, then you will get mocked by Cecilia Satterwhite forever. And I know this because the first time I put in a meteorite request like this, I tried to fill out the sample page as opposed to the blank page that comes directly after it. And she's just never let me forget that. So just keep that in mind. But again, it all comes back to paying attention to the details that are outlined in the request and then following the rules. And so I'm not going to go through the other 7 collections because each of them, Gemma already talked about it a little bit, and the links are here for where to find the information, and each of them is fairly similar to each other. And I'm mostly kidding about Cecilia. She's really nice, but she's from New Jersey, so it's sort of it's a different scale. So. All right, so let's talk in a little bit of detail about the most important things that you can do as you fill out your Astromaterials sample request. So you've gone to the website, you've downloaded the template, or you know what's supposed to go into it, but are all parts of it equally important? And they're all important, but some things are more important. And so first thing that kept coming up is include a title. Seems like an obvious thing. About half the requests I get don't have a title. If you don't have one, I'm going to make one up for you. You might not like that title, and depending on what kind of day I'm having, there might be good reason for you to not like it. So no, but include a title. It sets the stage for everything you're going to talk about and sort of gets us off on the right foot. The next thing, and the thing that came up with every curator I talked to, was be sure to fully define what science question you are addressing in the proposal. Now, it's important to have a well-defined project with clear testable results or a clear outcome. Now, not everything is hypothesis-driven science. So what do I mean by this? Don't change the slide. Sorry. What do I mean by this? Be specific. So don't say things like, I'm going to measure iron isotopes in moon rocks and figure out how space weathering works. All right. That is a proposal, but there's no detail in it. And so there's no way to critically evaluate how well it's going to be able to be done. It would be better to say you're going to measure iron isotopes in nanophase iron particles in lunar regolith grains, and the presence of heavy iron isotope signature would tell us this, or the presence of low iron, light iron signature would tell us this. So try to give specific hypotheses so that it's clear that your proposal has a good chance of success. So once you've outlined what it is you're going to study, then you have to say what techniques you're going to use to study it. So you need to have a well-described methodology that you're going to use. And this includes the effect of the analyses on samples. So, just in particular, destructive analyses require greater justification for using. And so as you explain the methodology, you should be specific. And I've listed a few things here that are really important. These analyses need to have not been done before. I mean, it doesn't mean if you want to do argon on a rock that's already been argon dated 5 different times, you have to say why your data is better or why we should spend more material to recreate that same date. Why can't you use the existing data that's in the literature? There are reasons to redo measurements, but you have to explain what they are. You also have to demonstrate that you have an understanding of previous work. If you come in and say, oh, I'd like to do all this work, and you don't have any references and you don't talk about it, the panel might think, oh, they haven't done their homework. They don't know what previous work has been done, and therefore that's going to be a no maybe. And now you have to go back and redo it and address those issues. So whatever technique you're going to do, you have to show that it's robust and that it's been previously demonstrated. We don't let people practice on Astromaterials. So if you're a lab that does samarium neodymium measurements on the regular and you've got peer-reviewed publications that show that, then great. You should include those or at least cite the references, and you shouldn't have that much trouble. Now, if you've never done a samarium neodymium measurement, but you have the right instrument to do it and you know how to do it, then you might have to demonstrate in the request itself that you have the ability to do it. And then give details. So as the review panel is reading your request, they're going to try to critically evaluate whether the results are likely to be successful in answer the proposed question. And so let's say you want to do uranium lead in situ dating, and you have a nanosim, so you're going to use a nanosims. Does the nanosims have enough mass resolution? Will it get a good enough age date to answer the question you have or that you're trying to address? Should you use some kind of large radius sims or something else that would do a better job? So just because an instrument is there and convenient, it actually has to be demonstrated to be both to have the necessary sensitivity to make these measurements. I keep using isotopes because I read a lot of isotope stuff, but this isn't just about isotopes. And so, I mean, if you're doing spectroscopy and you want to measure, I don't know, you want to measure, you want to make IR measurements on a lunar regolith to see if there's water in there or to understand the hydration history of the samples, but you're planning to do it in a silicate box. You're going to do it in a cabinet. You can't measure, water bands through silicate glass. And if you don't say that you're not going to do that, you have to show that the analytical setup you have will allow you to be successful. And it's not just the analytical details, it's physical sample manipulation details as well. Like a lot of times people like to work on sieve soils. Now, we don't sieve soils, lunar soils, below 1 millimeter at Johnson Space Center. So you have to do that yourself. That's not easy. Showing that you can successfully sieve a material down to less than 10 microns or less than 20 microns or whatever the grain size is that you need for your work needs to be part of the proposal. Gemma mentioned Hayabusa and manipulating micron-sized particles. You actually, specifically for Hayabusa, you have to demonstrate that you have the ability, either through peer-reviewed publication or they'll send you a test sample, to move using a micromanipulator small particles around before you will be allocated your Hayabusa samples. And so all of these things are outlined on the website, but there will be, if you put these in your proposal from the start, things will go more smoothly for you. Let's see if I forgot anything. Okay. Right. So you've outlined your science and you've talked about your methodology and how you're going to do it. What's the next most important thing, or what's probably the second most important thing? Science question, and then What samples do you need? Over and over and over again, I got, what did it say? Justify the mass, justify the number of samples, justify the sample selection. And so being specific about what samples you need to successfully complete your study is important. And the more detail you can give in this process, the better. Don't just say you need a moon rock. If you're trying to study basalts, talk about basalts. If you're trying to talk about carbonaceous chondrites, talk about carbonaceous chondrites and what kind of carbonaceous chondrite you need. This will be important for a couple reasons. So showing that you understand the sample collection that you are requesting from enough to request the right kind of sample is important. If you don't get the exact 5-digit number, say you didn't know that you want soil 60050 and you asked for 61050, okay, if you've already explained you need a highland soil that's mature, that has certain properties, then just getting the number wrong won't be a fatal flaw. It'll allow the review panel and the curation office to help you with the samples you need. It's more than just understanding the kind of sample or the type of sample you need within a collection. Sometimes it's about demonstrating which collection the sample should come from. So, I heard Gemma talk about pre-solar grains, and you can get those from stardust, you can get those from cosmic dust, you can get those from meteorite. And so justifying why you want a stardust sample instead of a cosmic dust sample to answer a pre-solar grain question is important. Cosmic dust samples and meteorite samples are renewable. We are collecting more of them. Stardust samples we aren't collecting any more of. So I'm not saying it's harder to get a stardust sample for pre-solar grain, but you have to make the case why you need a stardust sample versus a cosmic dust sample. And the same would be true for OREX. Just because OREX samples are new doesn't necessarily mean they're the right sample for your study. Maybe a regular, plain old carbonaceous chondrite would be more appropriate. And so if you make this case ahead of time in your request, then you don't have to iterate back and forth, either through multiple sample requests or, a back and forth with the curator. And it's important to provide backup samples if possible in case something isn't available. So you really want to study a lunar anorthosite. So you know about the Genesis rock 15415. So you just ask for that. But if that's not available, because that's one of our smaller ones, then providing other anorthosites that would work as well, or explaining why other anorthosites wouldn't work. And you definitely need 15415 or definitely need a certain Martian meteorite is important. Specificity is your friend here. It's not just about showing which samples you need, it's about justifying the number of samples you need. We get a lot of requests for all the samples. I'm going to study lunar basalt, so I would like 50 lunar basalts. It's like, okay. Or in this case, what did I write? Do you really need 37 CI chondrites? Nobody needs that many CI chondrites, right? This is just to see if Gemma kills me or not. It's about scaling it. So if you're studying if you want, let's say you've developed a new technique and you're going to measure ruthenium isotopes, and you're going to unlock the history of the solar system based on variations in ruthenium isotopes. Well, if you can't demonstrate that ruthenium isotopes or whatever isotope system you're looking at actually has variations, then you don't need a whole bunch of samples in the first go round in order to look at small variations within those, right? What you need is 3 or 4. You need a few samples across different reservoirs to show, look, ruthenium isotopes are important. And then you come back later and you're like, okay, now I've shown it's important, but now I need to look at all the archondrites or something and try to understand some important aspect of ruthenium isotopes. I picked ruthenium because I didn't think anyone was studying them, but I'm pretty sure someone is. Somebody's studying everything. So. And again, be sure to provide D-scope options or a ranked list of samples. This is sort of like the backup samples, just in case you ask for a bunch and you haven't demonstrated that you need a bunch, but you could get a few. It'd be better if you say which ones are the key samples before, so that the committee can understand that you know enough about these samples to study them well and to sort of make their life easier. Making review panels' life easier is always in your best. Your best interest. So, and then make sure that your attempts to address heterogeneity are relevant. And I already mentioned this, with whether you need to study all the samples right off. But just because like OREX has what, 8 different pie trays. Are the different pie trays really different? We have, is studying heterogeneity across those important? You have to make that case. If we're looking at lunar regolith from the Apollo 16 site and you want to look at what do they call mature soils? Well, but are there really significant differences between all the mature soils? Would studying 10 of them be any more relevant than studying 2 or 3? So you have to make the case why those extra measurements are important. And finally, and certainly for samples, and certainly not least, justifying the mass of samples you need in detail is super important. Now, I realize for some of the smaller particles, mass may not really be relevant, and you're not going to talk about the mass of Genesis you need or the mass of cosmic dust. I mean, in those cases, it's probably the number of particles. But for samples where we measure the mass, the larger collections, justifying the mass is one of the most important things, and you have to be specific. If you require 1 microgram of zinc in order to make your isotopic measurements properly, then you have to do the math. You have to figure out the concentration in the rock, multiply it out, and show that you need 1 gram at, I shouldn't have tried to do math in front of everyone, but you have to show that, you're not asking for too much or too little. And remember, too much or too little, both are bad. If you need 1 microgram and you ask for 5 micrograms and don't give a reason why, then you're not getting it. But if you ask for 1 microgram and you don't do the math and we give you half as much as you need and you end up with half a microgram and then you run it all through your mass spec and you don't get a good result, well, we just wasted that half a gram and now you need to come back and get another gram. So it's not just about showing that you need it's too much or too little are both a problem. And then for certain collections like meteorite, where you have a minimum and a maximum mass that you put into the request, you have to demonstrate for both. So the minimum means I get to run 1 replicate, say, and the maximum means I get to run 5 replicates. You're not done. What is the difference in data quality between 1 or 3 replicates that you might run with the minimum versus the maximum? Is it a 1% improvement in the data? Is it a 10%? Is it a 50%? Because if it's a small improvement for a large difference in mass, then that's less of a good case than if it's a large improvement for a large improvement in the data quality for a relatively small increase in mass. And Astromaterials are precious. So justification like, oh, my sample cup holds 10 grams, that's not adequate. If you're going to do some kind of spectroscopic work and you're like, oh, this is my normal cup, it holds 10 grams. Nope, that's not going to fly. Make a smaller cup. Or say that I must have, say, 1 square centimeter of surface area in order to make my measurement. It needs to be at least half a centimeter deep so that you're not getting interference from the container. Explain why you need the mass you do. I'm developing an instrument and I would like 100 grams to run through my instrument to make sure it works. Well, maybe you don't have to test the whole instrument for a mission. Maybe you can just test the relevant parts with a smaller amount of mass. And so it's all about specificity. Right. What else we got here? So are all samples the same? Is it harder to get some samples than other? Yes. As curators, we like to pretend we love all of our samples the same, but just like parents, we're lying. We all have our favorites. And it's not about our personal favorites. It's about whether those samples are unique in some way, whether they have low mass or low pristinity, meaning there's low amount of material that's still left. So asking for those requires greater justification. So, Gemma mentions 382 kilograms of moon rocks. There are exactly 10.8 grams of creep basalts. That is a tiny fraction. You want to know what the most requested sample are? Those 2 creep basalts. But you have to show that your measurement requires an igneous creep basalt, as opposed to one of the dozens, really hundreds of other samples that have that same creep signature in it that are much larger and have much higher pristinity. And so if you're going to use special samples, and the special samples are defined on the website and they're called slightly different. I think they're called specials in the meteorite. And I think it's the rack list, the restricted access. I forgot what C stands for in lunar. But if you're going to ask for one of those special samples, it will require greater justification to get it because there's less of it left, and therefore we're running out of times we're going to be able to study it. Along the same lines, if you're going to destroy the sample as part of the analysis, this raises the bar for getting those samples. Doesn't mean you can't. We let people destroy samples all the time, but you have to have a more definitive chance of being successful if you're going to be destructive. And again, this isn't a cut and dry case. There's different levels of destructive. For thin sections or thick sections, gold coating counts as destructive. It might improve your, isotope measurements by a small percentage, but it also means that anyone who wants to study that later by non-isotope measurements is now stuck with a gold-coated sample, and it's ruined for them. If you're going to do SIMS or laser ablation ICP-MS on sections, if you're studying major phases that are huge and relative to the size of your spot, it's not really destructive. If you're gonna put 5-10 micron pits in a millimeter sized olivine, okay, there's lots of it left over for people to study later. But if you're going to take every zircon in a thin section and absolutely obliterate it with laser ablation, then then you might be the only one who ever gets to study that. So you have to explain why it's worth studying them all or studying a percentage. Along similar lines, not everything makes it harder though. Along similar lines, using return samples can lower the bar slightly, as this will allow additional science on on that subsample. So if I've sent out 10 grams of soil to someone who did a spectroscopic study of it, and they sent it back and it's only been exposed to air, and you want to do a different spectroscopic study, hopefully in a different wavelength, it would be a lot easier to give you that same 10 grams again than the data that the two different labs of different types of spectroscopy would be more directly comparable, and we're getting more science out of that same sample without having to dip into our pristine reservoir. And so it doesn't remove the need for you to be specific about why you need it, but if you can use return samples, that makes things easier. Now, this isn't relevant to all collections or even to all samples within a collection, but you can ask for it, and if they are available, we would be happy to use those. Speaking of sections, we prefer to prepare polished thin and thick sections for collections where this is relevant. Again, not all sections are making, not all collections are making petrographic thin sections or thick sections, but when we do, we want to make them ourselves. It's not that we don't trust you to demonstrate that you can make good ones. It's that when we make them, they have a known history and a consistent history, and so we prefer to do that ourselves. There may be reasons that you think you need to make them yourself, and in which case you're welcome to make that case, but it will require extra justification. And then as a more general thing, this is like, if you have any special preparation instructions that you need, it's really important to put them into the request for a couple of different reasons. So if you're going to study, again, isotopes or something, and you want and you need an interior piece, be sure to say that, because we don't want to send you an exterior piece that has been interfered with due to, I don't know, a billion years of cosmic ray exposure history, but it also will make you look better to the panel reviewing the proposal. If they know, well, you don't want to do ruthenium isotopes, so we're back to that again. You don't want to do ruthenium isotopes on an exterior piece because there's going to be complications, then, and you don't say that, then maybe you don't know, and maybe that lowers your case for getting the sample. So if you need an interior piece, if you need a single chip versus multiple chip versus fines, talk about the type of sample you need. If you have restrictions on, say you're doing a organic study, I'm sure you don't want nylon bagging. We don't use nylon in some collections, but we do in other, and nylon is a direct contaminant for some types of organic studies. Be sure to be very explicit about that. Same thing, if you're studying HSEs and you don't want metal containers, say that. Not just because, we might not notice and send it to you in the wrong way and therefore impact your study or waste some sample that got sent out and had to come back without ever getting used, but also because it'll make you look like you know what you're talking about, which I'm sure you do. Same thing with non-standard epoxy, or if you need EBSD polishing, explain all that, because if you ask to do EBSD measurements and you don't ask to have it colloidal, polished with colloidal silica, questions get brought up. So again, it all comes down to details. I don't know if I've been talking a long time. Okay. Right. So, all right, that was me going through, sort of the highlights of how I think you should do the different requests, and things you could do better to help your request go more smoothly. But we still come back to this, but there are so many samples. There are 2,200 random 5-digit numbers from Apollo. And so like Gemma walked through and showed some of the stuff we can do on our website. And so I think I'm going to try in real time, which I probably will regret. Hopefully you can still, don't pick now. Don't choose violence. All right, you can hopefully still see my web browser.
Yeah, we can see it.
Okay, great. So, all right, so here, we're back on the curation website, and if you need a lunar sample, right? You're an experienced lunar scientist, so you know which one you need, but you just want to double check. So you go into our sample catalogs, and the most important thing you want probably is this Apollo sample and photo database. So you go in here, and now you can look at all the different samples. And so you need 70017, and so you just search for that, right? And that's great. And so here's 7017. You get high level stuff there, and then on the second page, it gives you all the information we have about the mission, where on the mission, how much it weighed, pristinity, how much of it is left, how many thin sections we have, links to all the, I'm pointing at the screen like you can see that, that's great. All the different catalogs and stuff that we have. This is all the information about that one sample, sort of all collected together in one place. Okay, but say you're a little bit, you're not quite as experienced with the sample, so you need a basalt and maybe a high titanium basalt. So you can just go to basalt, and then you can say an ilmenite basalt, and you can search. And now it's going to give you all of our ilmenite basalts, all 184 of them across the multiple landing sites. But maybe you can do a little bit better than that. You need a bunch of it. So you're going to want one that weighs at least, let's call it 1,000 grams. You don't like Apollo 11, so you want Apollo 17. And since you're not going to ask for something you're going to get told no for, ask for something that's at about 70% of its material left, and then search. And then here you go. Here are the 6 high titanium basalts that come from Apollo 17 that are both greater than 1,000 grams and have a high enough pristinity that shouldn't be part of the decision making process if you're asking for a reasonable amount for your study. So you can do this for basalts, but obviously you can do this for any of the different missions, any of the different rock types, and that works. And you can search for photos and other things specifically, but all of that is included when you do that sample. So what else can you do? So I'm going to cheat a little. No, I'll do it the right way since people are watching. So Gemma mentioned the Lunar Sample Compendium. So you find the one you want. You wanted that 70017. You were right the first time. So you go into our into our compendium, and now you can find Chuck Meyer's version of what's important about 70017. Now these are slightly out of date, and by slightly I mean 10 years. So if you're looking for recent results, this is not the place to find it. But if you want to find the 40-year history of this sample up to about 2010, 2011, this is all accumulated in one place. So Chuck has gone through the literature and sort of mined out the relevant things, mineralogy, geochemistry. There's usually a table in here of isotopes. If there's isotopic measurements, you've got the full chemistry of the sample here. He even gives you some of the information about the subsamples, which we don't normally make on our put on our website. So this is all here for you. And so you can, what else? The only other one I was going to mention is that if we do have a lot of catalogs. So almost everything's digital at this point. And so here's a list of all the Apollo sample catalogs that have been made over the years. And if you wanted to go and find the Apollo 17 one, here's the original Apollo 17 catalog that was made. This is the PE catalog from Apollo 17. And so if you wanted to find 700, oops, you gotta have the right number. 0017. This catalog is super annoying because they decided to save that one digit and not call it 70017 and call it 0017. But anyway, you can go through here and find out the information, more information if you needed to do a deep dive. If you're wondering why in the world would you need to do this, because these catalogs are some of the only places that give you the history of how these samples came back to Earth. And so this is showing you that it came back in the bliss bag. And if you were to dig into this a little bit more, you would find out that perhaps this bliss bag sat in some water while it was in the container. And so that might be a potential source of contamination. So all of this information is on our website, and it does take a little bit of digging to find, but all of the links for this are put into the newsletter every time we put one out. And I'm just showing you lunar because time and because this is what I'm most familiar to, but meteorite has a nice one, and some of the other collections have a nice one as well. And so that works. All right, that didn't go as bad as I thought it was going to. Well, let's see if I can get that. All right. And, don't limit yourself to our website. There are other external sources. There's the Met Bowl. There's Randy Koratev's Lunar Meteorites website. There are other things like that. Peer-reviewed literature is good. It's important to do your homework. It's okay if you don't know everything about a sample or if you come to us with questions. But if you haven't figured anything out and you come to us with questions, you might run into grumpy curators. We're always grumpy, but grumpier. Right. So let's talk about the timeline a little bit, because this is a question I get a lot. So the review and approval process typically takes between 2 and 3 months between the request deadline, or when you've submitted your request, and when the decisions are given to PIs. Sample processing time after that varies depending on what you asked for, but the goal is to get all of the sample allocations distributed within 3 months after you are notified. So we try to get all the samples out to the PIs that they've requested within 6 months of the request. Does it always work that way? No. External factors, pandemics, hurricanes, the week-long power outage we're going through right now, those things do have an effect, but that is the goal, and that is what we're working towards. If you would like to come to JSC and participate in the process of, the processing of your samples, you're welcome. It will likely slow things down because there are permissions that we have to go through to get you on site. We have to find time when the lab's available. So, keep that in mind. You're welcome, but it won't make things faster. And then there's a couple more things. So after you're approved for samples, and we've talked about it, now there's 2 administrative things that have to be completed. The first is a loan agreement, which is a non-reimbursable Space Act agreement between NASA and the PI's institution must be completed. That is a non-trivial step. We just redid both our domestic and international loan agreements. So a lot of you who are current PIs are going to be getting new ones here shortly. And the most important thing I can say here is that if someone else at your institution is already an approved PI, find out what lawyer or what part of the contracts office at your university or your institution reviewed the previous loan agreement, and go to the same person. Every time a new lawyer looks at the loan agreement, they want to make changes. We don't really allow changes. It's very difficult and time consuming. And so if you've got another PI in your institution, talk to them, find out who signed it for them, and go to them. And the last thing is the security plan. And while the security plan changes a little across the different collections, some of the stuff is pretty consistent, which is in a mobilized safe, and it needs to be in a high security location. So your office might be okay, but your office can't be on the building master key where everyone can get into your room. And so that's something where you'll have to work with the individual curator to make sure your samples are relevant. So, all right. So I talked longer than I meant to, and I apologize for that. So let's just see. We want people to study our samples. We really do. We try to be very accommodating and help people get them, but we're never going to waste them. And so it always comes down to demonstrating that the likely outcome of your study is worth the amount of Astromaterials that would be consumed by the study. And so that's what you should be doing. Always give as much specificity as you can, do your homework. And so we are aware that this process never goes as fast as people would like, but being fast is not our number one priority. Ensuring the long and short-term health of the collections while enabling science is, and there's a certain amount of bureaucracy that goes with that that's unavoidable. And the curators and curation staff are always here to help you, but it helps a lot more efficient with folks who've done their homework enough ahead of time. So I think that is everything I have to say.